Hello, welcome back to my channel NTC. So today I am going to discuss the electrical part 7, and in this video I am going to again discuss some important oral questions. So don't waste the time. Let's start the video. Our first question is, in star delta connector, in star delta starter of a cooling seawater pump. It means a seawater pump is having a star delta starter. Pump started with a star connected and did not get switch over on the delta. It means pump started, but it did not switch over on the delta connection, because at initial our pump is started with a star connection, and after a few seconds it will 10 second or 15 second it will switch over to delta. Okay, depend upon our configuration. Okay, so how you will know at the watch keeping node. Suppose you are on the watch keeping and you start a pump, but it did not switch over from star to delta. So how you can notice this one? So what are the significance and what are the indications, how you can know it did not switch over? You have to tell this one. Okay, so first of all, you know, in star connection, why you are using the star connection? To reduce the starting current, because when you start a motor with a pump coupling, so it will take high current. If there is no star connection, if you directly start a motor with a pump connection, it will start taking a very high current, approx 5 to 10 times, like a dual starter. But in star delta, we reduce the current by 1/3 times of delta current. Okay, 1/3 times of a normal delta current, because motor running in a delta 440, and in star connection we are giving the reduced voltage. It means the voltage we are reduced in the star configuration, so that our starting current will also reduce. Okay, so with the help of current, when you see on the terminal like ampere meter is there, when you check the ampere, and when the pump did not switch over from star to delta, you will see your ampere will be less. Ampere will be like 1/3 times of your normal running current, 1/3 of normal current. Okay, so you can observe your ampere will be less. Okay, your motor performance will also less, because now motor is running on a low voltage. If there is a low voltage, motor RPM will be slow. It means motor RPM will be not according to your rated RPM. Okay, rated RPM. So you can observe this motor performance also. You can check the motor current also, and your voltage will also reduce at the star configuration. I already told. And you also know, in a delta our line voltage is equal to phase voltage in delta. Okay, but in our star connection, our line voltage is √3 time of phase voltage. Okay, so you also know from here our voltage is also reduced. Okay, you can also examine the starter panel also, check the indicator lights, because some starter panel having a star and delta indication lamp. If there is switch over, then there must be indication from star to delta. You can observe the indication also at the starter panel. Okay, and thermal overload protection. In some cases motor may trip, because if motor is running on a low voltage, the current will increase after a few time, and after that it will get overloaded. Okay, so from the overload protection you can check also ki it's trip or not circuit, and also the vibration and noise will increase, because the pump and motor is running on a low voltage. Okay, it means motor running on a low voltage, so there must be a vibration or noise should be there. Okay, so let go to discuss the another question. Difference between the thermistor and thermostat. This is the most important question, generally asked important question. I just mark it there, you can remember this one. So difference between the thermistor and thermostat, from which semiconductor the thermistor is made up of. They are asking about the material also. Okay, so I will just explain you a little bit, you can understand very easily, because this is not a big deal. So what is thermistor and thermostat? You know, the thermistor, I already explained you before, NTC and PTC, there are two type of thermistor, and thermistor is a resistant dependent. It means when there is a change in resistance, our thermistor is a temperature sensitive resistor whose resistance changes with the temperature. It means whenever there is a change in temperature, there will be a change in a resistance also. And there are two type of thermistor, NTC and PTC. NTC is the negative temperature coefficient. It means our resistance will decrease when the temperature will increase. That is the NTC. And in PTC, our temperature and resistance are directly proportional. It means temperature will increase, our resistance will also increase. There are two type of thermistor, I already explained you before, and primary used for the temperature sensing and measurement. I already explained you before also this one. Basically we are using the thermistor for the temperature sensing and measurement. Okay. And you also know, I already explained here, semiconductor where resistance is directly proportional to temperature, that is PTC type, and where resistance is inversely proportional to temperature, that is NTC type, used for temperature sensing and monitoring. Okay, this one. But now in the thermostat, here is a bimetallic strip. In the thermostat, basically a bimetallic strip we are using on a various purpose, for switching on off, we are using in a fridge system also, we are using in a mixer grinder also, because if there is a increase in temperature, it means they will trip the circuit and disconnect the circuit. Thermostat is a basic function. There is a bimetallic strip. When the temperature increases, the bimetallic strip will bend and disconnect the circuit, it means trip the circuit. Okay, so they will protect our equipment also. Thermostat we are using in a fridge system also. And thermostat is a temperature control device that activates or deactivates a circuit as a specific temperature. Okay, whatever the temperature is set on a thermostat, based upon that it will activate or deactivate the circuit. They are basically used for this purpose. Okay, used for temperature control in heating or cooling arrangement. I already explained you, basically we are using in a heating and cooling arrangement, we are using in a fridge arrangement, we are using in a motor also, sometimes thermostat we are using, mixer grinder also we are using thermostats, and overall relays is there. Operates as a switch that turn and off and off. Okay, so these are the basically two, thermostat and thermistor. So what are the material we are using in a thermistor? They asked about this material. We are using a magnesium oxide, nickel oxide, cobalt oxide and copper oxide. These are the material we are using in a thermistor. You have to remember this one. Okay, so these are the material. They are typically made up of ceramic conductor that consists of metal oxide. Okay, metal oxide, this one, magnesium, nickel oxide, cobalt and copper. Okay, so let's go to the another question. Types of induction motor. Rotary in the wound type rotor winding are provided as question. It means they are asking about the types of induction motor. Okay, types of induction motor I already explained you there before also this question. There are conventional type induction motor, double cage is there also, compensated type motor also, and wound motor also. Okay, wound type motor also. These are the basically types. You can remember this one. Let's go to the next question. What is thermionic semiconductor? This is a very good question, because most of the time they are asking the thermionic semiconductor, because it has two different purposes. Okay, I will just explain you. A thermionic semiconductor refers to a material or a device that exhibits the both thermionic emission and semiconductor behavior. It means, I will explain you. Let's suppose here it typically combines the aspect of the thermionic emission, where electrons are emitted from a material due to the thermal energy. Okay, let's suppose there is some material, this is some material. Okay, and here are the electrons are just established on this material, and whenever there is a fall of energy, intensity or light, it means when it gains some energy, these electrons are gain some energy and excite from this place. Okay, it means the energy is greater than the work function of this electron, then it will excite from the place and move from one place to another place. Okay, it means, I will explain you. A thermionic semiconductor refers to a material or a device that exhibits thermionic emission and a semiconductor. It means it exhibits the semiconductor property also, but thermionic emission also. It means there are two type of behavior, thermionic behavior and semiconductor behavior. It typically combines aspects of thermionic emission, okay, where electrons are emitted from a material due to the thermal energy. It means in the material, when there is some electrons, here some electrons is there, whenever it gets some energy which is greater than this energy, it means the energy of the electron, it means whatever the work electron need to do to excite from this place to another place. So whenever it gets energy more than this work function of this electron, it will excite due to the thermal energy and remove from this place and go to the another place. Okay. So, these are basically thermionic emission. It means they gain some energy and remove from here this place. Okay. Electronic property of semiconductors such as ability to control current via the doping or external electric field. Thermionic emission, it means electrons gain some. Let's discuss the another question, this thermionic semiconductor. Okay. So, thermionic semiconductor refers to a material or device that exhibit both thermionic emission and a semiconductor behavior. It means it has two type of behavior. One is the thermionic emission behavior and semiconductor behavior. Okay, so let's discuss what is thermionic emission. Okay. In thermionic emission, electron gain sufficient thermal energy to overcome the material work function and are emitted in the surrounding medium. It's let's suppose this is some material where the electrons are here are some electrons, and when it gains some energy, it means when there is a rise in temperature, due to this it gains some energy and overcome the material work function and emitted from this materials to the surrounding medium. This is the surrounding medium. Okay. So, this is the basically thermal emission. It means it gains some thermal energy to overcome the material work function, whatever the work function of the material that have, and emitted into the surrounding medium. That is the thermionic. And semiconductor behavior I already explained you before also. There is the electron and hole movement due to the gain in energy. Okay. And whenever it gains some energy, it will start moving from n type to p type, p type to, it means electron to hole side and holes to electron to recombine, and there is a flow of energy in the semiconductor. Okay. So, these are the thermionic semiconductor. What is the microcontroller? That is our next question. Let's discuss. Microcontroller is basically a compact integrated IC. Okay, it is nothing just like IC. Microcontroller is IC. It means that totally all the work are done by the microcontroller. I will explain you. Integrated IC designed to perform a specific task. It means they have tendency to do the various type of task. Okay, it acts as a small computer on a single chip. It means it look like a single chip, and and this small chip is basically look like a computer. It means the function look like a computer. It means microcontroller having a small chip and it act as a computer to do the various tasks. Okay, containing a processor, CPU, memory, RAM, input, output, and peripheral. It means a microcontroller. What are the components it has? It has CPU, memory, RAM, ROM, and input output peripheral. Input output, it means input output, there is a sensor which is taking input from the field. Okay, which is taking input from the field and convert this signal into analog to digital and then give to the microcontroller, and microcontroller then execute the task. Okay, based upon the input and it will generate an output based upon the task. Okay. So, CPU is there to which is the main brain of this microcontroller, which execute the instruction and perform calculations. Okay. Memory, where we can store the data, and there are two type of memory, ROM memory and RAM memory. ROM, it means you store the program permanently. Okay, this is a firmware where we can store the program permanently. RAM we can use only for the random access. It means once you hold the data, after that sometime you can delete this data or randomly deleted this data. Okay, random access memory. This is not a permanent memory. We can use this memory only for the task purpose. Okay. Input output ports connect and control external device like sensor, display, and motors. Okay, it means whatever the input which is getting from the sensor, and based upon that the CPU execute the program, and based upon the programming, whatever we done the programming on a microcontroller, and based upon that program and whatever the output we want to generate from this microcontroller, based upon the input signal, they compare everything, and after that it will generate an output that is going to the some actuator, displays, and motor, whatever the mechanical or whatever the signal we want. Okay. There is a timer and counters also, communication interfaces that communicate from the various aspects. Okay, like UART, SPI, these are the not important you just understand the communication interfaces. Analog digital converter, I already explained you, whatever the input which is getting from the sensor, that is in analog form, we are converting into a digital form and then going to the microcontroller, and then microcontroller again convert into the analog and give to the output of the controller. Okay. So our next question is ACB contact material. Okay, they are asking about the ACB contact material. What are the ACB contact material? Okay, so you know ACB having the two contacts. ACB having the two contacts. One is the fixed contact and one is the movable contact. Okay, movable contact. These two contacts. So fixed contact and movable contact having the different material. Okay, so main contact which is made up of copper alloy, and the arcing contact is made up of silver tungsten. Okay, so arcing contact, why it's made up of the silver tungsten? Because it is high arc resistant and it can withstand with the high temperature. So this material is basically made up of silver, and the main contact will remove generally first, after that arcing contact will remove at the time of opening. So the main contact will contact very less time, and arcing contact arcing contact having the contact from a long time, and it basically extinguishes the all the arcs. So this arcing contact having a silver material and main contact having the copper material. These are the materials. Okay. Here also written fixed contact material copper and arc movable contact having the silver. Okay, so next let's go to the next question. How transducer work in a automation system? Basically transducer, I already explained you what is a transducer. The main purpose of the transducer is to convert one form of energy into another form. Okay, like temperature, pressure, flow, displacement, these are the physical parameters which we convert into electrical signals. It means whenever there is a temperature, pressure and flow in a system, and you want to measure this, what are the temperature at the field, what are the pressure at the field, what are the pressure of the machinery we have, you want to monitor these parameters. Okay, so how you can monitor this parameter? We have to convert this into electrical signal, then we can know the actual temperature and pressure at the field we are using with the help of a sensor. So how a transducer work in automation system? First is the sensing, after that conversion, and then signal processing, and then we transmit. Okay, so these are the basically function. Sensing, what we are using, the transducer that detects a physical quantity. First we are doing the sensing. In the transducer we are doing the sensing. It basically sense the temperature, pressure, flow, displacement using a sensor element. There is a sensor which basically sense this temperature, flow and pressure and flow, and then it convert this physical parameter into the electrical signal in a voltage form. Okay, into a voltage form or current form. This voltage form or current form, whatever the format we have, and after that there is signal processing. The signal processing is conditioned, amplified and converted as needed to ensure the accuracy, stability. Okay, after that it will be amplified and converted. And transmission, the process signal is sent to a controller, programmable logic controller or distributed control system for the further action, and then these parameters can be retrieved by this different PLCs and DCS to do the further actions. Whatever if you want to maintain a temperature, if you want to maintain a pressure, then you can know first the temperature and pressure at the field side, then you can do the further action based upon that. So what are the sensors we are using? Basically RTD sensors we are using, and pressure transducer we are using, and flow sensors we are using. Output transducer like solenoid, motor, valve control. Suppose you want to maintain a temperature in a chamber, and first you measure the temperature. If the temperature is not according to the set point, then this due to this error it generates an output signal, and which output signal is going to the actuators or like heating element like heaters to maintain the temperature inside. So like this we are doing. Okay, our next question is why use high voltage on ships? So what are the purpose of using the high voltage? We are using the high voltage of a ship because of the more and more power demand on a vessels nowadays, because we are carrying more and more reefers. We are using a high machinery, heavy machineries on board, like both thruster propulsion system, electrical propulsion system. So it all requires a high power demand. So we are using the high voltage on ship, and there are very advantages of using the high voltage, because higher voltage reduces current for the same power. Okay, minimizing loss in the cable and equipment, because if voltage will be increased, our current will be reduced, and due to this reduced current for the same power, okay, whatever the power we want, here what we do, we all just increase the voltage, so our current will be reduced, so our power remains same. Okay, power remains same. So by the help of this reduced current, there are too much advantage of this reduced current. Due to this, our what will happen, our machinery size will reduce equipment size, power capacity also improve. Higher voltage system can handle large power demands. Okay, essential for modern ships like heavy electrical loads. Reduce equipment size, lower current allows the use of smaller cables. Our cable size will be small, our machinery size will reduce, everything will be reduced. Cost will also reduce because we don't need to fabricate the big machineries, we don't need more and more cables. Okay, so these are the basically advantage. So we are using the high voltage on the ships. Okay, I will explain in further also. What are the cable insulation type of alternator? What are the cable insulation type we are using? That is EPR and XLP. That is EPR, it means ethylene propylene, and cross-link polyethylene. These are the insulation we are using in a alternator. Okay, our next question is what is JFET? Okay, junction field effect transistor. It's basically used for controlling the current. Okay, junction field effect transistor is a type of transistor that controls the flow of electrical current using a electric field. It means we are using electric field to control the flow of electrical current. It is a 3-terminal device: gate, source and drain. I will show you the picture now, and here you can see here source, drain and gate. They are the 3-terminal. One terminal is source, another the drain, and this gate. Okay, and now this drain and source is connected with a battery terminal, which is positive is connected with the source and negative is connected to the drain. And here this 2p type semiconductor is doped with a 1 n type substrate here, and this is our JFET construction. Okay, so this side basically this is the n side, this is n type semiconductor is connected with the negative terminal. So this side is forward biased, and okay, this side is a forward bias, and here this negative side is connected with the positive side. So this side is the reverse bias. Okay, so when you connect with the battery, that time this forward side electron movement will start flowing from drain to source. Okay, electron movement from drain to source, electron movement. Okay, so this electron is coming from this negative terminal and going to this side. Okay, to source side. So you know the electron flow and current flow is in opposite direction. So our current will start flowing from source to drain. In a JFET, our current will start flow from source to drain. But what will happen? Here p type semiconductor is doped with the n type substrate. So this p type is connected with the negative side, and this here n side is connected with a positive side. Basically this is in reverse biasing. Okay, this configuration is in reverse biasing. Whenever you increase this VGS, okay, whenever you increase this voltage, it means this depletion width is start reducing. So whenever you increase this gate voltage, this depletion width will be start reducing. This depletion width will be start reducing, and this current flow will be very less. Okay, whenever you start increasing this gate voltage, this width will be start increasing, and current flow will be reduced. So at a time will come when this current flow totally becomes zero, and due to the VGS applied, and the voltage at that time is called pinch off voltage. It means the voltage at which the current flow becomes zero, and then there is no current flow between the source to drain. That voltage is called pinch off voltage, and that is the function of JFET. We are controlling the current here with the help of the gate voltage. Okay, so this is the JFET. You can understand this very easily. So now let's move to the another question. Okay. SF6 and vacuum circuit breaker internal construction difference. What is the difference between the SF6 and vacuum circuit breaker? Okay, so in SF6 what insulating material is there, and insulating material in SF6 breaker is basically SF6 gas. Okay, and vacuum circuit breaker there is a vacuum. Okay, because we are using here vacuum for arc quenching, and here we are using the gas for arc quenching. Okay, in a SF6 breaker. So arc quenching high dielectric gas, and here in a vacuum we are using the vacuum interrupter for the arc quenching. Okay, so here in a gas SF6 breaker, gas filled complex. Okay, in SF6 we are using the gas, and here in a vacuum sealed vacuum interrupter. Okay, size, this SF6 breaker size is very larger and heavier, but in a vacuum compact and lightweight. Okay, vacuum circuit breaker are compact and lightweight. Environmental, agar environmental impact, high SF6 is greenhouse gas, because SF6 gas is sulfur hexafluoride gas is there, hexafluoride gas is there. Okay, so that this is not good for our environment. It increase the greenhouse gas in our environment, so it is not environmental friendly. But this vacuum circuit breaker is eco friendly. Okay, there is only vacuum chamber we are using for the arc quenching, and no any other harmful gases inside, so this is eco friendly. And it maintenance is high in SF6 breaker because of this gas carry, and in vacuum circuit breaker there is a very less maintenance. Okay, you understand this. So what are the safeties provided in the source supply connection? So source supply we already know, we are using in a dry dock, or let's suppose our vessel is at port. Sometime due to in some port we are using the source supply power, because there is some rule and regulation to use the source power, and that time we shut down our generators. We are using the source power to prevent the harmful gases in the environment also. Due to this purpose we shut down our generators. In some areas we are using the source power, otherwise we are using in the dry dock. So what are the protection we are using in a source power? Overload protection we are using, short circuit protection we are using, and earth leakage protection we are using. Okay, earthing and bonding is also there in a source connection is there. And after that, this voltage and frequency control, this AVR is there to control the voltage and frequency. Okay, there, these are the protections we are using. Okay, in fluorescent tube, how to increase the power factor? So how you can increase the power factor? By the help of capacitor. When you fix the capacitor with a circuit, they can easily improve the power factor, because here the current start leading. Okay, so you can install the capacitor. I already explained in the synchronous condenser what is capacitor, inductor, and how to increase the power factor, how to decrease the power factor, how to improve the power factor. Everything I can explain in my previous video. You can go and watch the previous video. Okay, and some electronic ballast having a very good regulating power factor. Okay, magnetic ballast tend to have a lower power factor, because we are using the magnetic ballast sometime, and there is an inductive coil, and due to this power factor will be reduced. But nowadays the electronic ballast replace the magnetic ballast, that can improve the power factor very easily, because there is a semiconductor device, there is no inductor inside, so it will not consume any power, and our power factor will be increased. Okay, for proper voltage, when you give the proper voltage to the tube light or fluorescent tubes, so ensure the voltage supply to fluorescent tube is the recommended range, then there the power factor will also improve. Okay, higher efficiency lamp you can use this one also. One surveyor asked this question, asked me to draw how capacitor bank is connected in a circuit. So capacitor bank how connected in a circuit? There are the these ways. Okay, how the capacitor bank in a delta connection capacitor bank, in star connection we are using in a star connection we are using a this capacitor banks. Okay, these are the types of configuration we are using. Generally most of the time we are using the delta only, delta configuration. Like this configuration we are using the capacitor banks. Okay, so let's move to the another question. Reverse power trip, what will happen? They are asking reverse power trip. If there is a reverse power trip, then what will happen? First generator will disconnect, load shift will start happening, and then we have to find the root cause. Okay, if next question, if the shift generator start but the breaker trips, what will the reason? One surveyor will ask, if the shift generator start but the breaker trips suddenly, and what will the reason? What are the reasons? Okay, there are the various reasons, like they are not properly synchronized. If they are not properly synchronized, due to this generator breaker will just close, and after that it will trip. Okay, if condition will not met, then let's suppose also ki there will be some overload because when you just close the breaker, and that time what will happen, suddenly there will be too much load is connected to the generator, and due to this overload happen. So due to this also breaker will trip. Okay, some mechanical problem also maybe happen in the ACB under voltage relay. There will be under voltage relay fault will be there, or maybe there will be under voltage, so that it not able to close the ACB. These are the basically chances of ACB to trip. Okay, other fault also, some mechanical issue also inside the breaker, you have to open and check is there any damage inside the breaker, so it will just trip the breaker. So these are the basically chances. Okay, so let's move to the another question. Advantage and disadvantage of the liquid cooling shift generator. Okay, advantage and disadvantage of the liquid cooling shift generator. So what are the advantage and disadvantage of the liquid cooling shift generator? Liquid cooling shift generator, you are basically know about the air cooled shift generator. Basically nowadays we are using the air cooled shift generator, but sometime in some vessels also the liquid cooling shift generators also. So what are the advantage and disadvantage? What are the advantage? Because the thermal efficiency, liquid cooled generator are more thermally efficient than air cooled generator. Okay, more thermal efficient than air cooled generator. Okay, noise level, liquid cooled generator are quieter than air cooled. It means the noise level is also very less in liquid cooled generators. Performance wise, liquid cooled generator perform more consistently in a different external condition. It means in different external condition like temperature, whatever the temperature, ambient temperature, they are working consistently. Okay, liquid cooled. And what are the disadvantage of this? Heavy maintenance. Okay, they require too much maintenance. Liquid cooled generator require more maintenance and care than air cooled generator. Okay, cost also high. Liquid cooled generator are more costly than air cooled generator. Okay, and what are the general issues coming in a liquid cooled generator? Can have issue with the coolant leakage, pump failure, radiator blockage. These are the common issues. Okay, generator size are also larger of liquid cooled generator size having the larger than the air cooled generator. Okay, let's move to the another question. Our working of BWTS, ballast water treatment system. You also know there are the two standard, D1 standard and D2 standard, and what are the standard. This I will explain you in next video, because this is another topic. Now they want to know about the working of ballast water treatment system and its trips. Okay, so how the ballast water treatment system is working and why we are doing this? Because to remove the invasive species, whatever the species, bacteria that are in our sea water, that are in our ballast water, before discharging into the vessel, we have to treat this ballast water, so it will not harm our marine life or environment. Okay, so we have to treat that, and if the condition will be met, then we can discharge only to the sea. So how you can basically treat this water, ballast water, before discharging? We are first doing the filtration. Okay, so we are doing first filtration, remove the dirt and microorganism or the larger particles than 50 microns. It means whatever the particles are present in our water, we are removing the dirt, microorganisms and larger than the 50 microns. So, we do the first filtration process will be there. They can remove all the microorganisms, all the particles that are greater than 50 microns. Okay. Then they are sent to the UV chambers where we are doing the chemical treatments also. Chemical used to remove the microorganism. If let's suppose there are again some microorganisms which are coming again to the UV chamber, so we can use the chemical to remove the microorganism and treat with the UV light to kill the organism. Okay, and treat with the UV light to kill the organism or bacteria. Okay. After that we are doing the deoxygenation. After that we are using the deoxygenation. How we can do the deoxygenation? Deoxygenation, it means we can remove the oxygen. So, how you can remove the oxygen? By filling the nitrogen inert gas. By filling the nitrogen inert gas. Here we are injecting the nitrogen inert gas. So, the deoxygenation takes place and it basically takes 2 to 4 days in a sealed tank. Okay, there is a tank where the ballast water will fill, and after that we fill with the inert gas, and due to this the oxygen will be removed here and all the bacteria and microorganism will kill already whatever the present in the tank. And after that it will be going to the heating chamber where we heat this ballast water. Okay, where we further heat to kill the all the remaining organism of bacteria, and then we can discharge some overboard if the condition will be met according to the BWTS. If the condition will met, then we can discharge overboard, and we can take the some portion from here to again feedback to the filtration side. Okay, this is a closed cycle which is running like this. First we do the filtration, then UV treatment, then deoxygenation, then heating, and after that we discharge overboard, and if the condition will not met, it will again go back to the filtering process. Okay, so this is the working of BWTS. CO2 extinguisher and working and operation. Our next question is CO2 extinguisher working and operation. You also know CO2 we are using for extinguishing a fire. Okay, a carbon dioxide fire extinguisher work by displacing oxygen from a fire triangle. So, you also know there is a triangle which is a fire, heat and oxygen. So, by removing the oxygen we are extinguishing the fire with the help of CO2. Okay. So, CO2 basically displaces the oxygen from a fire which suffocates the flame and puts out the fire. Okay. So, how it works? When a handle, the CO2 extinguisher is skewed, you see the CO2 extinguisher having a one safety pin and a handle. When you remove this pin and squeeze this handle, then pressure inside the extinguisher is reduced, then pressure inside the extinguisher will be reduced. When you squeeze this handle, due to this pressure will reduce, and due to this reduced pressure, this volume will increase. Okay, so volume will increase. So, this pressure inside the extinguisher is reduced, causing the liquid carbon to convert to the gas. So, due to this volume will expand and it will convert from liquid to gas, and then gas is released at a high speed, and then this gas is released with a very high speed to extinguish the fire. Okay. So, I already explained you the working also. Let us move to the another question. Fire extinguishing arrangement for the paint locker. Fire extinguishing arrangement for the paint locker. This is the safety questions are coming. I will explain in the safety part, but let us discuss this small question. Fire extinguishing arrangement for the paint locker. What are the arrangement we are using for extinguishing the fire at a paint locker? We are using a sprinkler system there, and CO2 system and DCP system should be there. Okay, these are the three systems we are using for the fire extinguishing arrangement for the paint locker. Let us move to the another question. Which starter you will choose, a star delta starter or auto transformer type starter? Why? So, one surveyor will ask which starter you will choose, star delta or auto transformer. If you choose star delta or if you choose auto transformer, but why and what are the reasons for choosing that starter also. So, let us discuss this star delta and auto transformer starter. Star delta starter, basically the motor starts in a star configuration. Okay, first the motor will start in a star configuration, it means the voltage will be reduced that time, and we are giving the reduced voltage and reduced current to start a motor, and after that we will switch over to delta, give to the normal full voltage supply to run a motor. And why we are giving the first star configuration? To reduce the starting current. So that's why we are providing first the star configuration, after that we switch over to the delta to giving the full voltage to run a motor. Okay, so what are the advantage of using this star? The reduced starting current, about 1/3 of the direct online starting current. Okay, so it's 1/3 of the dual starting current. Let's suppose you are using a dual starter. With the help of dual starter, when you start a motor, it will take very high current, like 5 times or 7 times of a starting current of a motor. Okay, so we are reducing the starting current to about 1/3 of the dual starting current. Okay, limit the initial torque also. So it can limit the initial torque also, because torque is directly proportional to the current. Okay, which is beneficial for high inertial load, simple design and relatively low cost. Okay, so what are the disadvantage of this? Require a motor with a star delta compatible winding. Okay, so the motor which is basically compatible winding having the star delta configuration, then you can put the star delta starter. Not suitable for all type of load, especially those requiring high starting torque. Suppose you want to run a motor with a very high starting torque, then you are not able to use this star delta, because it will not provide you a high starting torque. Okay, so for high starting torque you have to do the another configuration. You have to go for the auto transformer starter. Then the transition from the star to delta can cause a mechanical stress also. So there is a basically changes from the star to delta, and due to this there is a sudden voltage surge will be there, and due to this mechanical stress will happen. But in auto transformer starter basically uses auto transformer to reduce the voltage supplied to the motor during startup. Here also we reduce the voltage because there is a tapping, and based upon the tapping we are providing the voltage. We are basically providing the reduced voltage at the time of starting, and when start rotating with a approx synchronous speed or full speed, then we can provide the full voltage. Then voltage is gradually increased to the full supply voltage over a specified time. And what are the advantage? Provide a smoother and more control start with the adjustable voltage level, because there is an adjustable voltage level with the help of the tapping, and can start motor with a high torque requirement without significant. There will be no stress, and there is no sudden changeover from star to delta like this. Okay, suitable for wider range of the motor and types. Okay, and what are the disadvantages? More complex and expensive. These are the auto transformer more expensive and more complex system than star delta. The auto transformer can be bulky and require more space. More space is required for the auto transformer. Higher loss in the transformer compared to the direct starting. Okay, so these are the basically things about the tacho generator and pickup sensors. What tacho generator, you know, basically we are measuring the speed and RPM with the help of the tacho generator. Okay, so tacho generator is driven by a shaft and gives an output voltage proportional to the speed which is indicated the rotational speed of on a meter. Okay, so basically it provides the speeds which is driven by a shaft, gives an output voltage that is proportional to the speed. Output voltage is directly proportional to the speed. Okay, whatever the voltage is providing by the tachometer, that is converted into a speed, and this speed is basically shown on a meter of a tachometer. Okay, and there is a pickup sensor which is a magnetic pickup sensor type, and it's basically fitted near this flywheel. Suppose your flywheel, your ship propulsion flywheel will be there, and there is a MPU which is magnetic pickup sensor unit is there, and whenever it's fitted near the flywheel, and when the flywheel will rotate, due to this teeth, okay, due to this teeth, because this magnetic pickup sensor is connected with a supply, and due to this there will be some magnetic field will be there, and whenever there is this flywheel will rotate, and due to this teeth dimensions, this magnetic field will be changed, and this flux will be changed, and due to this change in flux there will be a voltage and frequency produced. Okay, whenever this magnetic pickup sensor is fitted near the flywheel, and this flywheel will start rotating, and due to this the flux will be changed, and due to this flux will be changed, an EMF will be induced, and due to this induced EMF it's produce a voltage and frequency, and it's giving to the control module. This voltage and frequency is going to the control module, which retrieve this speed of the flywheel or propulsion system. Okay. So magnetic pickup sensor, it is a device that measures the speed of a rotating part of a ship engine by detecting changes in the magnetic field. The MPU is mounted near the rotating part such as flywheel, camshaft or gear. When the teeth of the rotating part pass through the MPU, okay, let's suppose this teeth is passed through this MPU, it generate a voltage and frequency, okay, because there is a change in flux, and due to this voltage and frequency will generate, okay, because whenever there is a induced voltage, it's having own frequency, and the control module then convert this frequency into a speed reference, okay. So these are the basically